Um, Today's session is focused on erosion and stormwater related issues. And our first presentation will be hearing from Virginia McAnulty. She's with the Upper Chartiers Creek Watershed Association. And this is actually also a spotlight on one of our current GAPS program recipients. So we have a current GAPS program project with them, and it is focusing on Houston Park erosion monitoring. So I'll turn things over to Virginia. Thank you.
Hello, everybody. As was said, my name is Virginia McAnulty. I am the president of the Upper Chartiers Creek Watershed Association. I'm also the vice president of the Washington County Watershed Alliance. Not that that means a whole lot, other than there's not a whole lot of environmental work happening in Washington County. So I do like to point out what we do have. This particular project that we have is was developed by the Upper Chartiers Creek Watershed Association under the guidance of the Watershed Alliance. A little bit of background on us. We were established in 1999, so we're coming up on 25 years. The Watershed Alliance holds the 5013C, so they are our fiscal agent and they provide all sorts of support and help and guidance and ideas along the way. What we do, the Upper Chartiers Creek, is specifically, we really look for any kind of project that might help our creek. We have a sad situation. It is very polluted for a lot of different reasons. So part of what we do is public education. We host a wetlands walk with Dr. Jason Kilgore from the W&J College in Washington, PA. He's a fantastic speaker, very charismatic, very interesting. If you ever get a chance, I advise you sneak in on anything that he happens to be presenting at. We also do, of course, public education like every watershed association. You know, we go to fairs, we go to parks, we go to Boy Scout groups, we go to wherever we can go to get people to listen to us about what we might be able to do to help our creek. We also do what scientific research we can. We have been doing water monitoring, both macro and chemical, for about 20 years, possibly a little bit longer. So we have a lot of baseline. Baseline numbers aren't great, but it is a baseline, so it gives us something as we move forward. We also had volunteers assist the Pennsylvania Fish and Boat Commission. They did an electrofish survey of the entire length of Chartiers Creek. They picked about 12 sites and we had some volunteers go out and help them. Eventually we'll be getting that report. It's going to take a little bit of time, of course. It's Pennsylvania Fish and Boat. But hopefully when we get that, we'll be able to use that in conjunction to some data that we're getting from the 3RQ GAPS program to garner some interest in what we do and getting some projects off the ground. Houston Borough. Houston Borough is a small little place. They have about, roughly speaking, 1,200 people. Mayor, councilman, they are growing in terms of business, and they are interested in encouraging this project because they want to improve creek access for their community members. So it's been nice working with them. They have 3 creeks run through their tiny little borough, actually. One of them is our Chartiers Creek main stem, where we do water monitoring. The other is Chartiers Run, which is a tributary of Chartiers Creek. We also monitor that one. And then they have a third of fair size called Plum Run. It's a tributary to Chartiers Run, but we do not monitor there. All those creeks are impaired. All of them need attention. Chartiers Creek itself, I'm going to point out that the orientation on this map, north is pointed downward, which is a little bit counterintuitive to me. I usually have it pointed upward on the screen, but I wanted to point it out. I like this map because it does show the municipalities in the watershed. the Chartiers Creek watershed runs through 2 counties. It runs through Washington County. The headwaters are up around South Franklin, which is the top part of the screen, and through Washington County into Allegheny County, where it feeds into the Ohio River just west of the point at Pittsburgh. So my group, the Upper Chartiers Creek group, is concerned entirely with Washington County. We do not go into Allegheny County. We are talking more and more about trying to join forces because it doesn't quite make sense to us to separate a watershed by sort of arbitrary political boundaries of counties. So hopefully in the not too distant future, we'll be able to work together to address the entire watershed. In the meantime, we do focus on the Washington County portion, and Houston falls on the screen roughly a third of the way down the length of the creek. They are historical problems in Washington County, lots of agricultural runoff, of course, acid mine drainage from historical mining. When now, happily, we are in better shape economically, but that's been leading to sprawling developments, both residential and business. We also have some industrial contamination, both new and historical, and of course, wastewater is always an issue. So, oops, sorry about that. So why did we pick this particular spot? The pictures sort of say it all. We picked it in large part because we were there. We monitor there. We've been watching this slowly erode away for a good many years now. The project falls in omission because erosion control is mentioned in both our water management plan and our rivers conservation plan. And because it's owned by the borough, it's relatively easy to have a working relationship with the landowners. And of course, the Borough Council is interested in improving this site. They already have a baseball field there. It's well used by their community. It would be a fantastic advantage to the community to be able to access that creek for mostly fishing. There, you can boat on Chartiers Creek. This high up in the creek, you have to be pretty skilled in order to get through it during low water, but people do it. People do it and they love it. And if more people could get out in the water and enjoy it, I think it would really help us get our message out. This image shows where we want to plan the project. It runs on this image that we would be working along the left side of the bank. It's roughly 1,000 feet, just a little bit over, I want to say 11,200, something like that. The right side is actually owned by the Pittsburgh and Ohio Central Railroad. It's covered by vegetation. And for now, at least, it really doesn't need much attention. So how we got this all started, as I mentioned, we have volunteers out there all the time taking samples. And one of our volunteers decided to contact Houston Borough just to see if they'd be interested in joining us in this little adventure. And they are, which is fantastic. So then we went to Washington County Watershed Alliance staff and Washington County Conservation District staff and just ask what the next steps are. I am not a project planner. I am the project lead on this particular project, and I'm learning a lot as I go along. But like I said, we're all volunteer, and we can use all the help we can get, actually. So our volunteer went to the district manager at the conservation district, who then reached out to a colleague of hers who was an engineer, and he did just a quick sketch and a projected budget so that we had something. So we had some vague notion of what could be planned and how much it might possibly cost. This was a couple years ago. At this point, the budget is probably blown out of the water with inflation, but it is what it is. It's what we have to work with right now until we can get more data, more information to move forward. So our local conservation district director went to just informally contacted CNX, which is a natural gas producer, but they were not interested at that time. So then we had to sit back and think, and luckily we somehow came across the 3RQ GAPS program. And we looked at what they wanted to do, and we thought about what we needed in order to move forward, and it seemed like it was going to be a good match. So we contacted them. I personally met with Rachel at the Conservation District office. She talked about what they had to offer. I talked about what we needed, and it really did seem like it was going to be a good match. So we moved forward. And I have to say, I'm so happy I did. So Rachel created a plan to do the erosion study, which will also be analyzed and a report provided so that we have some facts behind us. We have some numbers. We can move forward as we're talking to people, as we're trying to get interest in our program. We are going to be able to use this information. I'm hoping, anyway, I'm assuming we'll be able to use this information as we are looking for money and as we're trying to generate interest. And that is pretty much us in a nutshell. I did want to give a huge thank you to everybody who's helped us. The Washington County Watershed Alliance gives advice and support. All the volunteers at Upper Chartiers Creek Group. It's unbelievable the number of hours and effort our volunteers put in. Houston Borough Council has been very welcoming and supportive. The Washington County Conservation District, none of this would have happened without them. I would not have even been able to talk to Rachel comfortably. We would have been sitting in a car having a conversation. So it was very, very helpful to have them. And then, of course, the West Virginia Water Research Institute, 3RQ, GAPS. I'm very hopeful and very enthusiastic about being able to use your skills and the reports that you can generate for us as we look for the help that we need. And that is Chartiers Creek in a nutshell.
Thanks, Virginia. That was great. So if you have any questions for Virginia, feel free to unmute yourself, or if you're more comfortable, to put it in the chat. It's really great to see all the collaborations, and Houston Borough being on board is a huge part of that. And then all of your really enthusiastic and energetic volunteers have been great. So thank you. So I know Virginia has to teach later this afternoon. So if you have any questions, now is the time.
All right, I think I'll be headed out. I'm sorry I can't hear the other two, but I have to scoot out of here. Thank you all for listening to me, and thank you again, Rachel and Water Research Institute staff and GAP staff. I'm very appreciative.
Thank you, Virginia.
Have a nice day.
You too. So we'll roll into our next presentation. We'll be hearing from Aaron Birdy, who is the Plan Build Manager at Upstream Pittsburgh, and he'll be talking about 9 Mile Run stormwater monitoring, and that's another GAPS program project. So Aaron, if you're able to start sharing your screen.
Yeah, I'm pulling it up now. Afternoon, everybody. Can you see my screen now? See my slide deck? 2 thumbs up. All right, that's what I like to see. Yeah, thanks for the introduction, Rachel. Happy to be here to talk about this monitoring project, one of many that I'm currently working on, that I think started in April of 2023, and I've presented on before, but I'm excited to give you some updates and share what we're doing with a wider audience here. So I'll give a brief introduction to Upstream Pittsburgh. We were founded in 2001 as the 9 Mile Run Watershed Association with the goal to restore and protect the 9 Mile Run stream, which runs through Frick Park, which is the largest city park in the city of Pittsburgh. Former, like prior to our organization existing, and the advocacy around 9 Mile Run, the stream was severely polluted, both with raw sewage and also industrial legacy pollutants. Slag is one of the largest, pollutants that we kind of had to tackle in 9 Mile Run. But in 2006, 2007, the Army Corps of Engineers completed the largest urban stream restoration project in the country at that time. I think over $7 million were spent on restoring 9 Mile Run. And I will go show you a map so that you can kind of see the area that we're looking at here for the monitoring project that I'm talking about now. So this map shows in the kind of yellow color the watershed boundary. All of the dotted blue lines are culverted portions of the stream. So storm culverts that carry the natural drainage through mostly Wilkinsburg Borough, but also parts of Edgewood, Swissvale, and the city of Pittsburgh. So our watershed spans multiple municipalities, and that has its own challenges, but also a lot of opportunities for collaboration. So the restoration project that I mentioned is outlined in this blue, thick blue line here, and that is the daylighted portion of 9 Mile Run, where it actually does flow, at the surface like a stream should, and not through a culvert like most of the boroughs it flows through. And then right here is right where the monitoring location is. The parkway is shown in a faint kind of gray line there, but the Parkway East and Squirrel Hill tunnels are like right here. So this is right underneath the parkway where we're looking at. So this is a view of the upstream end of the culvert. You can see kind of on the right wing wall here, there's a lot of deterioration of the concrete. In addition, there's a lot of crumbling concrete on the actual arch of the culvert too. It's a concrete box culvert with a solid bottom. So there are some issues with that regarding fish passage and also just general health of the stream. It is a significant kind of choke point for the stream. This is Commercial Street with about 2-3 feet of water over it. This is the guardrail that was in that last picture there. So when we get significant rainfall events, the stream floods out here, and it's in the floodplain. And just for comparison, this is the Commercial Street and that guardrail during dry weather. So that last picture was taken September 2021, and we haven't had any significant flooding events like that since. But that's what we're trying to monitor through this project. So this was kind of our idea on the downstream end to monitor the depth, temperature, and conductivity of the water around the culvert, try and understand the hydrology here better and understand how the stream in this area responds to precipitation events. So the USGS did have a staff gauge and flow monitoring set up here, I think in 2008, right after the restoration project was completed. So we do have some baseline data, and more importantly for this project, we had a nice mount to work off of. So installing the stilling well and sensor was actually a lot easier here because there is existing infrastructure to work off of. So the data logger that we're using here is a meter group ZL6 4G cellular data logger. It's really nice because in theory, you don't have to go out and collect data ever or mess with it. You set it up, can check the data online, download data online, and that's how I've been sharing data with the waters database is I just download it and push it right up to the database, and it's really easy. And then this is Commercial Street right off to the side there, just showing kind of where this setup is in reference. Made sure that it's also out of the flood zone. Something to be concerned about here is losing equipment. So wanted to make sure it was out of harm's way. And then this is just an image showing the CTD sensor setup. We started collecting data on August 11th. That's when we actually were able to get out and install it. As you can see, there's a ton of Japanese knotweed around there, so it's a lot of fun to chop through that to get the sensor installed, and it's definitely constant battle to manage those invasive species and how they can kind of negatively impact the stream bank and stabilization of the stream bank along these edges, I guess. So this is just a chart showing the electrical conductivity starting on the 12th. I just took the first day of data off because there was some errors when I installed it, but showing the minimum occurred here. Oh, that date's wrong. Anyway, minimum happened here on August, it looks like 17th, of 0.121 millisiemens per centimeter. The max that we saw is 1.592. I don't know if those responded directly to precipitation events or some sort of pollution. I believe the high here, there was a water main break that led to a lot of sediment being deposited into the stream. So that's my best guess for why that there's a spike kind of in the middle of September. This is just a graph showing the water temperature. Again, max was I think a day after we installed it on the 12th, and 2 days after 75 degrees. And the min that we saw is 42.1. So not a significant amount of fluctuation, but it's what we would kind of expect with this kind of stream. And then this is kind of the more interesting data, at least to me, or for the purposes of this monitoring project. So this shows all of our water level and precipitation. The precipitation, the rainfall gauge, is located a few miles away and at another one of our monitoring sites that we're looking at for green infrastructure monitoring, but it's still close enough to give a good, accurate representation of the precipitation in the watershed. So the base flow on average is about 25.61 inches or 2.13 feet over the monitoring period. The maximum that we saw was 61.97 inches or 5 feet, 5.16 feet during about a 2-inch precipitation event. So you can see the graph kind of spike and correspond to that really heavy rainfall event, which I think happened August 25th. So in addition, we're trying to reference like where the sensor's at and how the cross section, basically build a cross section profile and see where those depths fall. So this was completed on the 12th of October, and we did it, the standard of looking downstream, starting with the left bank and working towards the right. So you can see the top of the left bank up here, left bank full. The left bank is significantly larger and more eroded, flatter, whereas the right bank is kind of constrained by private property on the right. So the interesting thing here is because of where we took the cross section and because of the fact that it's the end of a culvert, typically the thalweg would be in the middle of the stream for most streams. In this case, it's actually closer to where we have the sensor located. There's a lot of sediment deposition that happens right in the middle, right where the water kind of exits the culvert and the stream becomes naturalized again. And this is just the blue line shows the depth of water when we took the survey, and then this green line shows the maximum water depth. That picture that I showed you with the flooding, the water was probably up at this 104 mark. So we haven't seen any significant flooding like that, but I'm hoping that if we do, we'll be able to catch it in the data and report on it. So the other part of this project that I've planned but haven't actually installed yet is using what's called LSPIV monitoring. So the USGS has been experimenting with this, and there's also some an open source kind of community that's trying to utilize cameras as a non-intrusive way to monitor flow and understand how the hydrology of certain systems. So this Pi Open River Cam is the open source, always evolving, I guess, GitHub platform to kind of learn about this and basically set up your own LSPIV monitoring setup. So the idea is that you would set up a camera adjacent to the flow of the river, add in these different control points throughout the field of view, also have a staff gauge to reference as well. And then you can use the software to predict the velocity and analyze trends in the flow of the stream. And this is a little bit better of a view where it actually shows the kind of three-dimensional aspect of it. So again, showing the control points, staff gauge, and the field of view. So in order to find the best place to put a camera, I had ideas at first, but after doing that survey and realizing how high the water gets, didn't want to put the camera in harm's way. So we have a drone, and I was able to fly the drone to a certain elevation and see what we can see in the field of view. And this is the AOI, I guess, for the camera once we install it. Again, this is just a drone image, which you can use to do the LSPIV monitoring as well. It's just a little bit trickier to try and set up. But this is the goal is to get a camera attached to this tree so that we can essentially look at the staff gauge, which is located here, add control points throughout the field of view, get the location of those, and then bring all of that into the software to actually start analyzing. I think that's it. Yep, that was my last slide. So, oh, thanks, Becca, for putting the link in the chat too. But yeah, thanks. And I'll turn it back over to Rachel.
So, excuse me. Thanks, Aaron. Again, any questions, you can unmute or put them in the chat during the presentation or right now. And while we're waiting on that, I do want to mention, for those of you who aren't familiar, I've mentioned the GAPS program. These are two of our current GAPS program projects. This was a new program that we started last year. Essentially, it's a mini grant program to watershed groups, especially focused on collecting data that will help with funding proposals for remediation or restoration projects of some sort. And coming up this year in 2024, we changed up this year's request for GAPS program, and it's more focused towards small colleges and universities. So I'll put the link in the chat for some information on that. If you know anyone who might be interested, feel free to share that around. And it looks like we had one question in the chat so far from Brian. How is the knotweed being managed in the watershed?
Yeah, thanks, Brian. I think that's a question that a lot of people have about invasive species management. Knotweed's always the prime suspect. But we do have a urban eco steward volunteer program that works in Frick Park in the areas kind of adjacent to the stream to manage invasive species and try to establish native species. In addition, they also work at our green infrastructure sites to do the same thing and try and control knotweed among other invasive species. So that's kind of where we're at. We typically use mechanical methods. We never really spray anything. And yeah, that's how we manage it, but it's always a constant battle.
Great. There's another question in the chat. Is there a dollar amount related to maximum grant funding? And this might be for Rachel about gaps, actually.
Sorry, I was muted there. So I think I'm trying to look back on the information that's out there just to make sure I'm not saying anything incorrect. But I think we set the maximum ask for $10,000. So these are small scale projects. That money could be used for helping with student funding or analytical costs. And then we'll also provide some services that aren't reflected in that cost, like providing the waters database, assisting with any uploads to that, assisting with collaborations with partners and making some connections there. All right, any other questions for Erin? Our next presentation, so we talked about, these are stormwater issues. So we've talked about erosion and flooding. And next we're going to talk about another issue that is common with a lot of stormwater, which is E. coli contamination. And so we'll be hearing from Emily Huff. She is a student research associate with West Liberty University, and she's going to be talking about E. coli monitoring in Upper Ohio River Valley streams. West Liberty University is one of our 3RQ partners for the Upper Ohio River. And so our main partner there is James Wood, who is also on the call. Hi, James. So take it away, Emily.
Yes, thank you. So I'm going to be talking about the coli monitoring that we've been doing in Upper Ohio River Valley streams. So bacterial surface water contamination, how bacteria gets in the water and contaminates these surface waters, there are multiple ways, whether it's failing infrastructure or wildlife walking around in these streams or our sewer systems. So in this image, during dry weather conditions, everything is flowing from pipes or storm drains to the water treatment plants. But when we get wet weather, like in the right figure here, these sewer systems reach capacity. So then these combined sewer overflows, or CSOs, open up and then discharge raw sewage directly into our streams. So pathogen contamination is the #1 cause of impairment according to the Clean Water Act 303D listed waters. And stormwater is a major transporter of these pathogens to surface waters. So we have these things called fecal indicator bacteria, and their presence alone can indicate contamination. But they are limited because these fecal bacteria have many hosts, so you're not able to distinguish between sources. So you don't know whether it's coming from waterfowl or deer or humans. So that is where E. coli comes into play. So E. coli is a bacterium. It's found in the guts of warm-blooded animals, and it's recognized as the best indicator of fecal contamination because its ability to then survive in the water once it reaches water. And the EPA sets safe limits for E. coli. For a single sample reading when you go out and collect is a 235 CFU per 100 milliliters of water. And then for a geometric geometric mean of over a 30-day sampling period of 126 CFUs per 100 milliliters of water. So how do we sample for E. coli? IDEX is a company that the EPA recognizes and uses to do sampling. So they have collection bottles that are 100 milliliters. So we take those out into the field with gloved hands, obviously, go out into the middle of the stream and collect a water sample. Those samples are then stored on ice until returning to the lab, and they have to be processed within 6 hours. Typically, we also take out a field blank to identify any cross-contamination that may occur. And then once you're back at the lab, there is an IDEX cola powder that is added to those 100 milliliter samples. It's then dissolved. The samples are then poured into a 97 well IDEX quanti tray, which is shown on the right. It is sealed through a sealer and then incubated in a 37 degrees Celsius incubator for 24 hours. And then after that 24 hours is up, you take them out. In the trays under regular light, the wells will be a yellow color if there are fecal coliforms present within the trays. And then once you put them under a black light, the wells will fluoresce, and that indicates that there is E. coli present within that sample. We count each of the wells up, and then that gives you a most probable number of E. coli that are present within the sample. So our studies, we wanted to first start broad, and we looked at the entirety of the Wheeling Creek watershed. So the Wheeling Creek watershed is roughly 760 kilometers squared. It houses Wheeling Creek, fifth water stream, has roughly 25 active CSOs. It's impaired by old infrastructure, mining, and development, while the upper portions are affected heavily by agricultural, but the whole watershed is impaired by fecal material inputs. So the study we did encompassed the upper portions of Wheeling Creek and then the lower portions within the city's jurisdiction, because the city wanted to determine whether the fecal material and the E. coli present in Wheeling Creek was coming from the upper portions or was it within their jurisdiction. So on the right, the upstream portion is below this blue line, which is the 126 CFU geometric mean, meaning that the E. coli at the upper portions was lower and below safe limits. Or once we got to this site called County Line Bridge, which starts the city's jurisdiction, the E. coli concentrations got higher within the city's jurisdiction, meaning that there was E. coli inputs increasing once we got to the city's jurisdiction. So we then wanted to concentrate on the tributaries that were coming into Wheeling Creek at the lower portions. So we focused on the long run watershed to look at how that watershed was contributing to Wheeling Creek. So the long run watershed is this purple watershed over here. It houses a first order stream. The area is heavily urbanized with extensive deer populations, and it is also impaired by fecal material inputs. So we picked 24 sampling sites along long run, sampled in June and August of 2023 over nine time points. And we sampled during dry weather conditions, so it's after 72 hours of no rain. So this figure has a lot going on in it. I had 24 different sites that I was sampling, but looking at it, the dotted line here is the 235 single sample reading line. All of the sites averaged above that safe limit. So we wanted to determine where else was of interest, where else is creating, bringing in a lot more E. coli to Long Run, which is then bringing it to Wheeling Creek. So we wanted to look at these two sites here on what we call Orchard Run. It's Orchard Stream. So we focused in finer on a smaller geographic area to look at the E. coli coming in from there. So we picked 6 sites and sampled in October and November over 6 sampling points after no rain during those dry conditions in a much smaller area. And we found that in our downstream area, E. coli is much higher than the upstream portion. When we look at Orchard Run 3 and 4, so the red star and yellow star, we look at it on a map, they are not very far apart. Where the yellow star is, it goes underground into a culvert and comes out at number 3. There's a huge jump between number 4 and 3. So somewhere in between there's an influx of E. coli entering the stream in a very small area. So what we do with this information is we work closely with the Wheeling Water Pollution Control Division, and we give them all of the data that I've collected and has been collected previously for them to go out, and they've done dye testing, their lines and people's lines to see if they can determine if anything is leaking or not, to then reduce the amount or hopefully eventually be able to eliminate the amount of E. coli that is entering each of these streams in the watersheds. So moving forward, we want to continue looking at the previous tributaries sampled and then other tributaries that might be contributing to Wheeling Creek. So with that, I'd like to thank the Wheeling Water Pollution Control Division for sponsoring this by allowing us to purchase the E. coli materials for the IDEX through our queue and Dr. James Wood. That'll take any other questions.
I actually have a question, Emily. Great job. Could you explain the reasoning for dry weather sampling, and also did you do any wet weather sampling?
Yes, so the reason for dry weather sampling is when it rains, it's opening up those CSOs and bringing an extensive amount of water to the creek that's going to disturb the sediments that are on the creek that houses the E. coli, because the E. coli does attach to sediments. So we're looking at what's just there on a regular basis, because after a while, the E. coli that's attached will die and it won't have an impact, but we want to see what's coming in all the time that's actively alive and can create problems. And not for the long run and the Orchard Run stuff I did recently, I only did dry weather, but for my thesis stuff, I did collect during wet weather, and the E. coli concentrations were exponentially high after a wet weather event happened than after dry weather.
To add to excuse me, to add to what Emily said, our baselines are so high, and the wet weather tends to increase it because of CSO discharges. And if we're trying to find failing infrastructure, we really need to focus on the pipes themselves. And so that's our best opportunity is nothing coming in terms of runoff, CSO discharges. It's simply, our pipes leaking, and really beyond pipes leaking, we're probably dealing with some illicit hookups or some illicit, accidental, forgotten hookups. And that seems like what's going on at that Orchard Run site is that there is essentially an abandoned line that's not actually an abandoned line. And the city is going to have to spend some time trying to figure out where that is. But they were able to identify a line that they all were scratching their heads going, we don't know where this goes. It shouldn't be active, but that's the only pipe that comes in under that paved section. So to kind of boil it down, the dry weather gives us the best look at the infrastructure's baseline leaking.
Thank you. Any other questions?